What are the properties of this DFT? You get bored one of these days because every transform I will be referring to will have the same properties. One property is the periodicity. This is periodic because if you substitute here m as n plus m, then this becomes same as this. So, this becomes a periodic Fourier series. The periodicity is as an outcome, we can do nothing about it. Although the signal x of n is having only finite number of samples, this expression for DFT will result into a series of n's which are automatically, that sequence is a periodic sequence. Because again of this fellow, because it is periodic with respect to n here. Number 2 is it is linear. Linearity, you know what it means, alpha x1 n plus beta x2 n will have a Fourier transform DFT equal to alpha x1 m plus beta x2 m. So, the transform is linear. So, apply the linearity principle on this, it comes out to be this. Most transforms we deal with again are linear transformation. The reason is quite simple, because if you are going to one domain to another domain, you always have to come back from this domain to this domain. Unless there is a linearity, you will not be able to do this inversion uniquely. That is why every transform we apply has to have a linearity property. It is invertible. If you have product of two functions, the transform of this will be what? Convolution of the Fourier transform of this and this, that is x1k, x2 m minus k summed over k 0 to n minus 1 is the Fourier transform that. It is easy to prove by just substituting this and rearranging it, you will end up this. So, if you are not convinced, you go home and do it and you will get this. What about the Fourier transform of a convolution? Ulta. This is a bit tricky. So, let us try to find out what this really means. Let us take a simple example of 3 samples. X1 n has 3 samples. X2 n also has some three samples, not necessary, but let us say it is also 3 samples. Okay. What does convolution mean? You say this is this is this, and this is this, just to distinguish. So, what is the convolution operation? From this definition here, you can see that you invert it over the value of n and then change the value of n and then go on moving it for different values of n and see where this coincides and multiply it and get that value is equal to, are you with me or not? For a given value of n, this n here, this sequence is written down other way around, centered around. So, when n is some value, you get some sequence like this. This sequence you multiply with this sequence. That value is the value of the convolution at the given value of n. And you go on changing the value of n, then the sequence, inverted sequence will go on moving like this because n is changing, right. And at some stage it will come to all three of them will match. Then after that it will again go and the number will be matching will be less and so on and so on. But the fact remains that these are finite sequences. When there are finite sequences, when this n is such that this inverted sequence comes like this inverted sequence, say this is 1, 3 and 2 and this becomes 2 and 3 and 1 inverted sequence. When it comes here, what do you put here and what do you put here when you multiply? Because the sequence is only defined for values 1, 2, 3, 4 up to n minus 1. But to do this multiplication, I need something here. So, what can you do? You put a 0, right. So, now what effectively you are doing is, you are increasing the size of this to match the size of this for all possible translations. If the one sequence is n of length equal to capital N, other sequence also is of length of capital N. So, how many zeros you will have to add as you are moving it? N number of zeros, right. So, you are making artificially x1 n or x2 n as equal to 2n sequence, 2n minus 1 sequence. Okay. So, in that n of them are what is given and remaining are zeros. And the convolution will end up into length equal to n minus 1. Do this example for different values of n, you will see this. So, the length of the convolved one will be length equal to 2n minus 1 and each one has to be now defined now artificially for length equal to 2n minus 1 and then so this remaining values which are not given by you by earlier, you put zeros there. This way of doing convolution is what is known as a linear convolution. Are you with me or not? Yes? No? Somebody says yes or no?
Sir, they need more graphical interpretation.
Huh?
I guess we have to draw more pictures of those.
Okay.
The secret version and how we can do all that.
All right.
More graphical interpretation.
I thought you are more intelligent than me. So, when n is equal to 10, let us say, n is equal to now 3, 5, some number more than this, then what does n minus x2 n minus k will look like? This axis is k and this is 0, 1, 2, 0, 1, 2. Okay. If n is 5 and if k is 0, this value must be x2 equal to x2 5 and x2 5 does not exist because you are only given values corresponding to 0, 1, 2. What do you do then? So, you put a 0 So you go on putting how many zeros until if there is any match here. The number of zeros to make sure that these are taken care will be equal to almost the same number as this. That is how the 2n minus 1 has come. Then they will be able to say that these three are matching with these three. Because whenever you multiply these two, the number here has to be multiplied by some corresponding number, and this corresponding number has to be defined, and the sequence does not have those values, all of them. So you will put zeros for that. So this way of doing convolution is what is known as a linear convolution. Okay? Just do some example at home like this, taking different values of n, then you will find that unless you make the length equal to 2n minus 1, you will not be in a position to find out the, whenever you have to multiply, you have to have some defined value for the other one.